Good morning and good evening, everyone. Hopefully you can hear me. Excellent. Thank you, Sheree, for sharing my charts. And Danny, again, yes, thank you so much for those inspiring words. And we really are just thrilled to have this partnership with JAXA to get the first pressurized rover onto the surface of the moon and help us as a science community address some of these really high priority science objectives in the South Polar region of the moon. Um, I, I also very much appreciate Ryan and Dr. Inatomi for putting this workshop together. We really love this dialogue with the science community, this opportunity to engage and hear from you what your vision is and what your ideas are for how we can use these um, these transformative elements on the lunar surface to advance our science objectives. Tonight, or in this morning, I'm going to talk a little bit about the lunar science, Artemis lunar science overview from NASA's perspective. So if you I think go to the next chart. Thank you. So from NASA's perspective, we go to explore for a number of reasons. We believe humans go to space because there's an inherent benefit of space exploration to humanity, and exploring as one world together, we can achieve more than doing this alone. So we believe very passionately in these three pillars of exploration for why we explore. Certainly, uh, you know, leadership, inspiration, and science. And science is of course from the science side of NASA, our key motivating factor for going to these unique places across the solar system, to answer some of the fundamental questions that we have about where we came from, why are we here, where are we going, and it's a really intended to be a very cross-disciplinary exploration endeavor. So science, on the science pillar, encompasses all, it's a very cross-divisional, cross-disciplinary motivation to go and explore. So uh, leaning on this very fundamental foundational pillar for why we explore, the rest of this presentation will talk a little bit about more detail about those science objectives from NASA's perspective. So the next chart talks about, just very briefly, this is a QR code to access this document that NASA released several years ago now on our Moon to Mars strategy and objectives development. And this was a publicly released document, so you can access it. I think that these charts will be made shareable, so you can access it later too. But the next chart talks a little bit more, highlighting the different tracks of these objectives. And if you click next one more time, so we have, oh, you might have to click next 4 times. I'm sorry about the animation. But yes, perfect. Thank you. So there are 4 tracks of objectives that we highlight in this blueprint, in this strategy and objectives document. And again, leaning very heavily on this presentation about the science side of things, but they're also transportation and habitation. How do we live and get to the places where we want to explore, the infrastructure to support that exploration, and the operations, or the actual how are we going to explore with humans on those 3 tracks. But the science track is a little bit more broad, and it's really, in all of these together are intended to create a blueprint for sustained human presence and exploration throughout the solar system. But as Danny highlighted, human exploration is only a part of the whole story, and uncrewed exploration is, I mean, obviously we've been doing that very of planetary surfaces pretty consistently over the last several decades, at least on Mars for the last couple of decades, and the moon before that. But having this opportunity looking forward to learn again how to live and work in a sustained manner on the lunar surface to prepare us for pushing us human presence and human exploration farther out into the solar system, and using the moon as a key linchpin for that exploration is a really great opportunity for us to learn not only how to live and work in challenging environments, but learn about our nearest celestial neighbor in the sky. So if you go to the next chart, this is highlighting those science objectives, specifically that science track is broken down into 6 categories of science objectives. So we have lunar and planetary science, heliophysics science, human and biological science, physics and physical science, and that includes astrophysics as well. Then we have 2 other, so those are the 4 fundamental science tracks, and then we have science enabling and applied science tracks as well within the science section. And altogether, there are 26 science objectives that we are aiming to accomplish across our Moon to Mars exploration campaign. The rest of the conversation I'll talk about a little bit more specific, the really unique opportunities that Pressurized Rover brings to this story as well. So if we go to the next chart, I'll highlight that on the fundamental science side, we have traced those very carefully to our decadal surveys. So NASA asks the National Academy of Science and Engineering and Medicine to strategize for the next 10 years what science objectives are highest priority to those science disciplines and those science communities. So we try really hard to trace back everything that we're doing to these documents as guiding lights, if you will, for what we're trying to accomplish with our exploration programs and campaigns. And that's on the science mission director. So the science side, there's also, of course, the human research program. So if you go to the next chart, we're also driven, including some of those research objectives in this science track. And their guiding principle is and goal is to enable space exploration, human space exploration beyond low Earth orbit by reducing the risk to human and health and performance. And I'll go into that a little bit in detail too. Of course, that is primarily, of course, on the crewed mission side, and we're talking about the uncrewed for the rest of this workshop. But I did want to underscore the opportunity that Pressurized Rover brings to enabling HRP or human research as well. Okay, so then the next chart is looking at what high priority science objectives we can accomplish with Pressurized Rover. Again, Pressurized Rover is a unique vehicle. It's the first of its kind to operate on the surface of another planetary body. And we're extraordinarily excited about the opportunities this vehicle gives to us as the science community to address and make progress towards addressing our objectives, both during crewed and uncrewed mission phases. So I won't read through all of this in detail in the interest of time, but highlighting at the high level those science themes that we're looking at for accomplishing with Pressurized Rover include solar system origin and early history, and I'll go through these in more detail in a moment. Geologic processes of early Earth as they're preserved on the moon. Volatile origin and delivery processes, human and biologic system responses, and then crew health and performance in Pressurized Rover. So if we go to the next chart, this ancient solar system record, of course, on Earth, that ancient terrestrial record has been erased because of the Earth is a very dynamic place. We have, of course, rain and water, wind, volcanic activity erasing this earliest record of what the solar system was like during the earliest time of Earth generation and formation, the onset of life. We don't maintain that initial ancient solar system record, while the moon does, and it's I quote, right in our backyard. It's still really far away, but and hard to get to, as Danny underscored, a very large challenge. But it is an excellent opportunity, a location where we can go to access some of that ancient solar system record. And by determining the age of those ancient rocks and dating the impact basins that formed during that ancient time, we can learn a lot more about what that ancient environment was like, Was it limiting to the onset of life, or would it enable the onset of life? And understanding that absolute chronology will anchor not only our understanding of the Earth-Moon system, but also across the inner solar system as well. It provides that anchor for that impact history and that impact record. If you go to the next chart, what Pressurized Rover can do for us in that particular example is Pressurized Rover can expand our exploration zone, getting us to more distant locations from our landing site, and accessing more geologic units or provide more opportunities to confirm the ages of identified features. We can do this by acquiring remote sensing data to characterize the lunar surface terrain, and characterize more fully some potential sites of interest for further exploration, whether that exploration is with crew or without crew present. And then, of course, we can acquire and return samples of lunar rocks and regolith to identify those ages and analyze those back on Earth. So this is a really great opportunity that Pressurized Rover can enable us to make some significant progress towards addressing the question and characterize the ancient rocks in the lunar South Polar region that we are going to have access to. The next chart, I'm going to fly through these last few charts. Study of planetary processes. So this in the South Polar region, of course, we're not going to access volcanic terrains, or we don't expect to, but we can access, again, some of the ancient crust in the highlands and many impact craters and basins. We're on the rim of the South Polarican Basin. So we have an opportunity to understand the variety of crustal compositions, the crustal rocks, as well as the internal structure of the moon with selective operations. So if we go to the next chart, what Pressurized Rover again brings to this story enables us to deploy geophysics instrumentation at strategic locations across the South Polar region, again, potentially with and without crew present. And then highlighting that this would be focused in the South Polar region, and getting to the key sites might need other deployment methods beyond Pressurized Rover, but Pressurized Rover in particular can enable us more extended access across the South Polar region to place these sensors and other instrumentation and characterize the composition of that crustal material to tie back to that geophysics information that we could get with this instrumentation. The next chart talks about some of the really, truly unique opportunities that bring us to the South Polar region is understanding the lunar polar volatiles. There are vast questions that we have about the distribution, lateral and vertical distribution of volatiles in the South Polar region, the composition that can drive us to understand where those volatiles came from. Is this a renewable source from the solar wind? Or is this an ancient source from volcanics or from comets and asteroid impacts? So Pressurized Rover can offer us an opportunity to gain access to more of these volatiles in very hard to reach areas or more distant areas that Pressurized Rover can bring us to. So the next chart kind of highlights that again of what Pressurized Rover brings to this story, but we can map the lateral and vertical distribution of volatile bearing units, characterize thermal properties and distribution of cold traps of all sizes across the South Polar region, and facilitate and crucially facilitate the transport of cold conditioned samples to preserve as close as we can the original state of materials until we can analyze them on Earth to constrain the composition and origin of lunar polar volatiles. The next chart, I just have a few more, is talking a little bit more about the human research side, so that human and biological science that Pressurized Rover enables, again, primarily during the crewed mission rather than uncrewed, because of course human research is tied to when humans are there. But this is talking about the goals and objectives and the incremental approach to the human research side in order to prepare us, collect the data that we need in order to prepare us for exploring more distant destinations like Mars. And so the idea is to gain additional information of long duration sustained operations of humans on the surface of the moon, and to figure out how to prepare us again for exploring Mars. So the next chart talks a little bit more in detail about the specific uh, factors that the Human Research Program is investigating. And we're talking about like the radiation environment, isolation and confinement for extended periods of time, distance from Earth. Certainly the moon is farther away from home than ISS and low Earth orbit. So getting that data with increasing distance from Earth. Altered gravity, so partial gravity, how do humans react and respond to that? And then hostile enclosed environments. So those are the focus areas, and we can make significant progress in learning about the human system, especially during the more extended missions that Pressurized Rover is going to be enabling. So the next chart is kind of my walk-off chart. So this is kind of looking a little bit in more detail at some of the objectives that NASA has identified, really at a very high level of lunar exploration, and how we think Pressurized Rover can help us make substantial progress towards addressing those objectives. But this conversation is turning this back around on you and asking you what you want to do with Pressurized Rover, especially during this uncrewed phase of the mission. So we're really excited to hear the conversations and discussions that happen over the course of the next couple days and nights, and to hear what you have to say and what your ideas are. So thank you so much for having me and for being here to have this really exciting conversation.